Hi guys, it's Mrs. Tucker. We're going to start a little project here. It's a activity that helps explain functions and how they work, and you guys are very familiar with this. It's an algebra-based project, and it's going to get you ready for high school. Okay, so let's get started. This is called Valentine's Day Ideas, and this is activity 1, so it's the first part. The school's drill team has contacted several flower distributors and has narrowed the choice to 2 companies. Option 1, Roses Are Red has offered to sell its roses for fixed down payment of $20 and an additional charge of 75 cents per stem. That means per rose. Option 2, Flower Power has offered to sell its roses for a fixed down payment of $60 and an additional charge of 50 cents per stem. Which one is the more economical offer? At Roses Are Red, they are charging 75 cents per stem, where at Flower Power, they're charging 50 cents per stem. Okay? Well, I'd rather pay 50 cents than 75 cents. But there's also a down payment. A fixed down payment of $20 at Roses Are Red, where it's a fixed down payment of $60 at Flower Power. So which one do you think is the better deal? I want you guys to make a prediction. Which one should you buy at? So let's switch over to this page. This page says, Activity 2, using tables to find the more economical offer. From the description of the 2 offers, complete the chart to find an algebraic rule that will determine the cost of n number of roses. Okay, so we've got this table. You're going to start off with number of roses. You're going to use 10 roses. This is your process column. This is your cost at Roses Are Red. Here's your process column for Flower Power and the final cost for 10 roses at Flower Power. Okay, I'm going to get you guys started, and then you guys are on your own to finish filling this part out. Okay, now Roses Are Red, what was that offer? Roses Are Red is a fixed down payment of $20 and 75 cents per stem. So, in your process column, it was a fixed down payment of $20 plus, what did it say, 75 cents per stem? 75 cents per stem for 10 flowers. 75 cents per flower times 10 flowers. Well, if you take 10 and multiply by 0.75, you get $7.50. If you add that onto the 20, you get $27.50. Okay? Let's do it for 20 roses. They have a fixed down payment of $20, and then it's 75 cents per rose times 20 roses. Okay? Well, if it was $7.50 for 10, it's going to be $15 for the 20 roses. $15 added onto this is $35. Okay? So you guys are going to finish doing this column here on your own. I've got it started for you. I know you know how to finish this out. If you guys want to use a calculator on this, I will let you do that. Okay? Let's look at the process column for Flower Power. Let me go back and see what they said. Flower Power said they're going to charge $60 down payment, but 50 cents per flower. So let's do that. $60 down payment for Flower Power, but they're only going to charge 50 cents per flower. And we're going to buy 10 flowers here. So if you take 50 cents and multiply by 10, you've got $5. $5 added onto 60 is $65. Okay, What if you buy 20 flowers? Well, there's a $60 down payment, plus you still have to pay 50 cents for every flower, and that's 20 flowers. We're going to buy 20 flowers this time. So if 50 cents times 10 is $5, then 50 cents times 20 is $10. You add that on to 60, you've got $70. Okay? I want you guys to finish filling out this part of the table. So when you're done, you should have this all filled out. I want you to pause the video here. Let the kids finish filling this out. Okay, you guys should have had time now to finish filling out all 4 of these columns. When you got done filling them out, did your numbers look like mine? Let me see if I can scroll this down a little bit. Did your numbers look like mine? Take a moment. We might have to pause the video here. See if you got what I got. Okay, so now we have to figure out what the expression is that goes in each one of these boxes. Okay, we're looking for an expression, and this time instead of calling the number of roses 10, 20, 30, 1,000, we're just going to call it n. All right, look in your process column. What numbers never change? It looks like that 20 never changes. The addition sign never changes. And the 0.75 or 75 cents per stem never changes. So down in our box down here, in this box right here, we're going to write 20 plus 0.75. What are all of these numbers here that are always changing? Yeah, this is your variable here. That is this column here, and we're going to represent the number of roses by the letter what? Yeah, n. So that's what goes here. So our expression for the cost for any number of roses is going to be 20 plus 0.75 n, where n represents the number of roses that you purchase. Okay, well, let's do the same thing over here for flower power. What never changes? Yeah, the $60 up front never changes. The addition sign never changes, and the 50 cents per stem never changes. What are these numbers that are always changing here? Yeah, that's your number of roses. So down here in our process, we can write that the cost at flower power is 60 plus 50 cents for every flower times what? Yeah, times the number of flowers. So does your expressions for the cost for both look like mine? Okay, great. Let's move on. Let's go to the bottom of this page. At the bottom of the page, there's 2 questions. It says write a sentence and a function rule for the cost of the roses from roses are red. Okay? They charge a down payment oops, that's in the way. Down payment of $20 plus what? 75 cents per stem. They also want you to write the function rule. So we're going to say cost equals what? 20 plus what comes next? All right, good. I want you guys to do number 2 on your own. Do the same thing, but I want you to do it for flower power. Question number 3. What patterns do you observe from the table of values? All right, let's go back to the table. I want you to look for some patterns. Okay? I notice right here I'm increasing by 10, increasing by 10. Each time the number of flowers increases by 10, what's happening here? What's happening here? Here I have an increase of 30, 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 increase of, here we go, 30. All of these through here are increasing by 30 flowers. What's happening here? Whoops, not there. What's happening from here to here, from here to here, from here to here, all the way down? What's happening from here to here with the other company? Okay, these are the patterns I want you to talk about for that question. All right? Pause here. Let everybody observe the patterns and write down what they notice. So go ahead and give it a pause. Question number 4. What happens to the cost of the roses as the number of roses purchased increases? What would a graph of this relationship look like? Okay, now you got two different companies, so I want you to answer it. What happens to the cost of the roses as the number of roses increases? What does the relationship look like? Okay, and you can write it out or sketch yourself a little graph. This here would be the number of roses, and this would be the cost. Write down what you think would happen. You can make a little sketch about what you think it'll look like. Pause here. Number 5, how many roses can you buy from Roses Are Red for $65? How many roses can you buy? Pause the video here. And along those same lines, on question number 6, how many roses can you buy at Flower Power for $65? Pause the video here. Question number 7. Which company offers the better deal? Pause the video here. Question number 8. Is there a point where the two flower dealers charge the same total amount? If so, what is the charge? If not, why do the costs never equal? Pause the video here. Question number 9. Write an equation that represents the point where the two flower shops charge the same amount. Okay, so you're going to have an equal sign because an equation has an equal sign in it. I want to know, what are you going to put on this side and what are you going to put on this side? Okay, you're going to have an expression over here for the cost at one flower shop, and you're going to set it equal to the expression for the cost at the other flower shop. Pause the video here. Activity number 3, using the graphs to find the better offer. Find an appropriate viewing window for the graphs of both functions. Graph both functions and label here. Okay, I want you guys to start off doing this by hand. Okay, so I want you to title, the x-axis is always your independent variable and your y-axis is always your dependent variable. Well, in this situation, the cost that they're going to charge us depends upon how many flowers we order. Okay, so on our x-axis, we're going to label our x-axis number of flowers. How many flowers are we buying? And then this axis is going to be cost in dollars. And I want you to start at 0 flowers and $0. Go back and look at your tables, okay? I want you to start with the first company, Roses Are Red. And let's go back. Let me look at that table. There's one data value, I think we're going to skip that 1,000. Let me go back and find this. Yeah, let's just go from 0 up to 240. Let's see if we can graph that. Let's skip 2,000. That's a huge jump. So let me find my graph again, and I'll get you guys started. Right here. Okay, we're going to go 0 up to 240. So maybe we could go 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. That'd be 220, 240 would be about there. So I don't really have a lot of room down there. You'll write this below the line and label each one of those grid lines for the number of flowers. Now we have to take a look at our costs. What is the maximum cost for up to 240 flowers? Wish I would have looked at that when I was back there at the table. I know you guys have this right in front of you. Bear with me and I'll go back. We need to find our biggest cost. Let's see, it looks like 700, no. We're not using that one. We're either going to use that one or this one. So we need to go up to $200 on our y-axis. So back to the graph. Clicking through here, back to my graph. We have to go up to $200. From 0 up to 200. Let's see, could we go by tens? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. 10, 20, 30, 40, 50, 60. That's not going to get it, is it? Let's go by 20s. So 20, 40, 60, 80. There's 100. And I'd label each one of these 20, 40. You can do all of that. Okay, so 20, 40, 60, 80. That's 200. All right? I want you to graph both sets of data on the same grid. So you might have one set of data that, I don't know, maybe looks like this. And you might have another set of data that looks something like this. And I want you to label them. This is Roses Are Red, and this is Flower Power. Okay? You're going to graph all of the points, and then you're going to connect them with a straight line. I was just doing this real quick as an example. All right? So that's what I want you guys to have done by Monday. Okay, good luck.